So let's discuss introducing pandas objects. Will be the focus. So at the very basic level, pandas objects can be thought of as enhanced versions of NumPy structured arrays in which the rows and columns are identified with labels rather than simple integer indices. So as we will see during the course of this section, Pandas provides a host of useful tools, methods, and functionality on top of the basic data structures, but nearly everything that follows will require an understanding of what these structures are. So thus, before we go into the further details, let's introduce these three fundamental Pandas data structures, which are the series, data frame, and index. Okay, we will start our code sessions with the standard NumPy and and pandas imports like import NumPy as NP, import as PD. So the pandas series object. A pandas series is a one-dimensional array of index data. It can be created from a list or array as follows. So we will discuss this. Okay, now data is equals to pd dot series 0.25, 0.5, 0.75, 1.0. Got this. So as we will see in the preceding output, the series wraps both a sequence of values and a sequence of indices, which we can access with the values and index attributes. The values are simply a familiar NumPy array. So the index is an array-like object of type pd.index, which we will discuss in more detail momentarily. So like with NumPy array, data can be accessed by the associated index via the familiar Python square bracket notation. Sorry. My bad. Oh, that's one. And data one. So as we'll see through though the NumPy series is much more general and flexible than the one-dimensional NumPy array that it emulates. So now let's discuss series as a generalized NumPy array. So from what we have seen so far, it may look like the series object is basically interchangeable with the one-dimensional NumPy array. So the essential difference is the presence of the index, while the NumPy array has an implicitly defined integer index used to access the values. The Pandas series has an explicitly defined index associated with the values. The explicit index definition gives the series object additional capabilities. For example, the index need not to be an integer, but can consist of values of any desired type. For example, if we wish, we can use strings as an index. We close the bracket and So we got the output this. So and the item access works as expected. We can even use non-contagious, or non-sequential indices like data. 2537. Got the error, I guess. That's speedy. Okay, so now data results in 0.5. So now we will discuss series as specialized dictionary. So in this way, you can think of a Pandas series a bit like a specialization of Python dictionary. A dictionary is a structure that maps arbitrary keys to a set of arbitrary values, and a series is a structure that maps typed keys to a set of typed values. You can have the definition here. So this typing is important, just as the type-specific compiled code behind a NumPy array makes it more efficient than a Python list for certain operations. The type information of a Pandas series makes it much more efficient than Python dictionaries for certain operations. We can make the series as dictionary analogy even more clear by constructing a series object directly from a Python dictionary, like this. Population California. The numbers are 3 at 332521, then comma, then enter, then Texas, then 26448193, then New York, the number is 19651127, then Florida, 19552860, then comes Illinois, sorry, we have repeated the number. That is 12882135. I guess we have completed it. Put the same bracket here. Now, population is equals to pd dot series population dict. We got the result. Now, by default, a series will be created where the index is drawn from the sorted keys. From here, typical dictionary style item access can be performed. California. We got the result. Unlike a dictionary, though, the series also support array-style operations such as slicing. Now, I guess we got the spelling. I and O-I-S. Spelling looks fine. Oh, we put let's see. So we got this.